Okay, question 7. Assume that f double prime, the second derivative of the function f, is continuous. We're going to use L'Hopital's rule to show that this limit here, quite complex looking, is equal to f double prime of x. And notice this limit is with respect to h. So everything we're going to do here is going to be with respect to h. So if we consider the limit as h goes to 0 of f of x plus 2h minus 2f of x plus f of x minus 2h all over 4h squared. Now when we do limits, the first thing we usually try is to just plug the value in for the variable and see if we can evaluate the limit. And if we do that, notice that if h were 0, we would have f of x minus 2f of x plus f of x. And that would all result to 0 on top, and then 0 in for h on the bottom would give us 0. So we get 0 over 0, which is an indeterminate form. And that is why we're allowed to apply L'Hopital's rule, because we've got an indeterminate form. So we can use L'Hopital's rule and use that to evaluate the limit. And now this is where you have to be careful, because we're looking at the limit as h goes to 0. So we're looking at L'Hopital's rule with respect to h. So if we think about the derivative of the top and the derivative of the bottom, we're doing these with respect to h. So you can regard x more as a constant as you do this. You can think of it like that. And so when we do L'Hopital's rule and take the derivative of the top, we're going to have f prime of x plus 2h. Chain rule, derivative of the inside, derivative of 2h is 2, minus the derivative of 2f of x is going to be 0. There's no h there. Plus f prime of x minus 2h, chain rule there, derivative of the inside with respect to h is minus 2, all over 8h. So let's clean this up a bit. We've got the limit as h goes to 0 of 2f prime x plus 2h. And then the middle term is 0, so we don't have to write that. And then we have minus 2f prime of x minus 2h all over 8h. Now, if we were to evaluate the limit again, plugging in 0 for h, on top we'd have 2f prime of x, and then we'd have minus 2f prime of x. And so that would be 0 on the top, and then if we were to plug in 0 for h on the bottom, we'd have 0 over 0, giving us an indeterminate form again, allowing us to do L'Hopital's rule again, keeping in mind this is still with respect to h. So we've got the limit as h goes to 0 of 2f prime of x plus 2h, chain rule, times 2, double prime, derivative of the derivative, minus 2f double prime of x minus 2h, chain rule, times negative 2, all over 8. And so let's simplify this here a bit. We've got the limit as h goes to 0. I've got a 2 times a 2, so I have a 4 f double prime of x plus 2h. And I've got a minus and another minus, so that's going to become plus 4 f double prime of x minus 2h all over 8. Now, plugging in 0 for h is not going to give me an indeterminate form. I'm not going to get 0 over 0. I can keep going and evaluate this And when I do that, I'm going to get f double prime, oops, not 4 double prime, 4f double prime of x plus 4f double prime of x all over 8. And this is going to result in 8f double prime of x over 8. The 8's will cancel, and I end up with f double prime of x, the second derivative, which is what I was asked to show up here. Now part B is asking us to verify that expression using the function f of x equal to x squared. So let's write that down here. We need to verify that f of x plus 2h, whoops, the limit as h goes to 0 of f of x plus 2h minus 2f of x plus f of x minus 2h all over 4h squared is equal to f double prime of x for f of x equal to x squared. Okay, so notice that if I've got f of x equal to x squared, f prime of x is going to be 2x, and f double prime of x is going to be 2. So essentially what I want to do is I want to verify that this limit as h goes to 0 of f of x plus 2h minus 2f of x plus f of x minus 2h all over 4h squared is equal to 2. In this case, because our function is f of x equal to x squared. So I'm going to need to put in all these parts because now I know what f is. I know that f is equal to x squared. So let's work with this. I'm at the limit as h goes to 0, f of x plus 2h. Well, if f is x squared, f of x plus 2h is going to be x plus 2h squared minus 2 times f of x, so minus 2 times x squared, plus f of x minus 2h, that's going to be x minus 2h quantity squared all over 4h squared. And that we need to show is equal to 2. And when you're verifying a statement, you need to typically manipulate one side to show that it equals the other side. You don't move stuff around between both sides. So I'm going to do a lot of algebra at this point. Squaring this binomial means I'm going to have x squared plus 4xh plus 4h squared, because I'm taking x plus 2h times x plus 2h, and I need to multiply that out. And I've got minus 2x squared, multiplying out x minus 2h times x minus 2h. I'm going to get x squared minus 4xh plus 4h squared all over 4h squared. I need to show that that is equal to 2. So now I'm going to gather up like terms. Notice I've got a 1x squared, another 1x squared, that's going to equal to 2x squared, and then I've got this minus 2x squared. So those are all going to cancel because those are like terms. Similarly, I've got a plus 4xh and a minus 4xh. Those are going to cancel. So let's write down what we've got here. Got the limit as h approaches 0. I've got 4h squared plus 4h squared, so I've got an 8h squared over a 4h squared. I'm trying to show that that's equal to 2. And sure enough, the h squareds cancel. 4 goes into 8 twice. And the limit as h approaches 0 of 2 is just 2. And so I've got 2 is equal to 2, and I've thus verified it.